Now, last week we looked at the revision of our number patterns, sequences, and series. Today I've decided we do some paper 2 revision, concentrating on statistics. Remember, I know that in schools we have enough time to revise paper 1, but paper 2 always suffers a lot. Hence, I've decided also to move on to the first questions of paper 2 so that as we practice, we balance both papers. Our topic for today is statistics and regression analysis, as I have mentioned. Now, this is the paper 2 weighting, where we are saying statistics has between 17 and 23 marks. Analytical geometry has between 37 and 43 marks. Trigonometry has between 47 and 53 marks, and Euclidean geometry has between 37 and 43 marks. Now, this is the target that we need. For us to get a minimum of 45%, our target should be 12 for statistics. And for us to get a bachelor pass, we should get a minimum of 15 marks out of 20 for statistics. Now, these are the topics you are able to see yourself. I will not talk much about them. So normally our question paper is structured such that our question 1 and 2 are normally statistics, and we should be able to answer those questions. Now, moving forward, we have our information page. Always refer to the formula page so that you do not write wrong formulas. For paper 2, we mostly use this part. I've included the quadratic formula because sometimes we are expected to use it, as well as our analytical geometry, we use those formulae. And for our trigonometry, we normally use these formulae. Please always refer to your formula page. It helps you a lot. We move on now to the objectives. Now, we need to differentiate at the end of the lesson univariate and bivariate data analysis. We determine the 5-number summary and use it to draw, interpret, and comment on the skewness of a box and whisker plot. We have to identify outliers from a given data distribution. We have to draw and interpret an ogive and a histogram for continuous data. We draw a scatter plot, a line of best fit, and comment on the relationship that exists between the two data variables. By univariate, we are saying one variable statistics. Bivariate, it means you are comparing two variables that are related. So we determine the least squares regression equation, and we use it for prediction, as well as we should also use our correlation coefficient to comment on the relationship between the two variables. Let's move forward. Our pre-knowledge, we know a mean, mode, median, standard deviation, we know bar graphs, histograms, pie charts, frequency, we know frequency tables, we know our stem and leaf diagrams, ogives, cumulative frequency, scatter plots. So, data handling is a process in which numerical information is collected, recorded, represented, and analyzed. That's what data handling is all about. And data, it's facts and numerical information that is being analyzed. It can be grouped or ungrouped. For ungrouped data, this is a set of random data elements gathered for analysis, and grouped is the data elements aggregated into different groups or classes or class intervals. And we look at measures of central tendency, where we are saying this is a single numbers around which all data items seem to spread. We have a mean. It's one of the measures of central tendency. It is also known as the average, where we sum up all data items and we divide them by the number of elements in the data set, which we call n. And we use the formula x bar is equal to the sum of all data items divided by n. Now, for grouped data, we calculate an estimated mean, which is our X-bar estimate. Again, we use the frequency multiplied by the midpoint of the interval divided by the total frequency, or the sum of frequencies there, which is known as our cumulative frequency. And we are saying M is the midpoint and F is the frequency for that particular interval. We have a median. It is the middle most data item in an ordered data set. We order our data from smallest to biggest, and the middlemost position will give us the data item that gives us our median, known as Q2. The mode is the most frequent data item. In other words, the data item that has the highest frequency or that appears the most. Now, we can have more than one mode. And if there are two modes, we say it's bimodal. If there are three, trimodal, and so on and so on. For grouped data, our mode is the data set, or the group that has the highest frequency. We have measures of dispersion, where we are saying it describes the spread of the data from between minimum and the highest data item in the interval. So the range is the difference between the maximum data value and the minimum data value in the given data set, and we say highest value minus minimum value. Now, we have interquartile range, which is the difference between upper quartile and lower quartile, and we use IQR as the abbreviation for interquartile range, Q3 minus Q1. And then we have standard deviation, which measures how dispersed the data is around the mean. And we know that the square of the standard deviation will give us the variance, and the square root of the variance gives us the standard deviation. Now, our data can be analyzed and put into groups of quarters for us to see the spread of our data. And we are grouping the data items into quarters, and each quarter represents 25% of the data set. So if I have 16 data items, it means the lower quartile will be in position number 4, the upper quartile will be in position number 8, and the upper quartile will be in position number 12, and the maximum will be in position number 16. The minimum will be in position 1. That's how we group our data items. Now, the lower quartile is the data item below which a quarter of the data items lie on the data set, and we are saying for us to get the position, it is always given by 1/4 n plus 1. That's how we get our lower quartile. The upper quartile, which is Q3, its position is 3/4 n plus 1. We move on. The percentiles, we can group our data items into percentiles. We are looking at grouping our data items and positioning them from position 1 up to position number 100. Now, if I have 20 data items, it means I'm able to group them into percentiles as well. For me to get the position, if I want the 80th percentile, it will be 80/100 times the number of data items. Then I'm able to get the position of that data item. Now, this is the formula that we use. We move forward. We have a 5-number summary. In our 5-number summary, we have a minimum, lower quartile, median, upper quartile, and the maximum. And we represent our data in a box and whisker plot, and we use the 5-number summary. Now, we comment on the skewness of the data by comparing the mean and the median. If the mean is equal to the median, our data will be distributed symmetrically. If our mean is greater than the median, we say our data is positively skewed or skewed to the right. If the mean is less than the median, then the distribution is skewed to the left or negatively skewed. Now, if the data is symmetrical, we know that approximately 68% of the data items will fall within one standard deviation of the mean. And we use that interval for us to get the data items that fall within one standard deviation to the mean, this one. And we know that approximately 95% of the data will lie within 2 standard deviations to the mean. So we multiply our standard deviation by 2, we calculate our mean, we subtract, and then we add so that we get our interval. We go to our data set, we count the number of data items that fall within 2 standard deviations to the mean. Now, we also have outliers. These are data items that are either a lot bigger or a lot too low as compared to the other data elements in the data set. So for us to find the lower outliers, the minimum, anything that is less than our lower quartile minus 1/5 times interquartile range. In some literature, this is given by the interval Q1 minus 3/2 IQR. That's how we get our lower limit, and our upper limit is given by Q3 plus 3/2 interquartile range. So that's how we identify our outliers. Anything outside this interval becomes an outlier, and we are able to see that. Now, we also use an Ogive to represent our cumulative frequency curve. This one is letter S shaped and is drawn by plotting the upper limits of the class interval of the group data and also using the cumulative frequency of the data. We will illustrate this. We have grouped data where we are saying it's continuous data. This can take any number on a given scale of measurement. Now, you will always see that for continuous data, there are no gaps. You can represent continuous data using a histogram. And if we plot the midpoint of the class interval, we come up with a frequency polygon that is a closed shape. We just join the midpoints of our frequency of our histogram, So midpoints of our histogram, we plot them, then we join the points. We come up with a frequency polygon. Moving forward, the difference between a histogram and a bar graph. So we know that a histogram is used to represent continuous data, and a bar graph is used to represent our discontinuous data. Now, the model class is the class interval with the highest frequency, and a frequency polygon indicates the number of occurrences for each distinct class in the data set. Now, we know that we plot the midpoints and then we join them together to get our frequency polygon. And Ogive, it's our cumulative frequency graph, is also used to represent continuous data. The formula that we use, that's for the mean, that's for our variance, which will help us get our standard deviation. But for our purposes, we are allowed to just use a calculator, making our life easy. So when we are using our calculators, remember we have to be in the statistics mode. And for now, we are analyzing one variable statistic. It has to be like that. And then we are able to enter our data items. Remember to save. And as you do your calculations, make sure you write down all the information that you can before you can even start looking at the other questions. Just calculate everything and then use that. I would want us to go straight into the first activity that I have for you, and I will give you 9 minutes to answer those questions. Welcome back. I know maybe 1.3 was a bit of a challenge because we didn't have a grid, but I would encourage you should be able to plot it even without a grid for practice sake, so that you must know how to do it on your own. Now, let's move forward and we quickly mark the table. Remember, we said for us to get an estimated mean, we find the midpoint of every interval. So how do we find the midpoint? It is the lower value of the interval plus the upper value we divide by 2. So this will be 50 plus 100 divided by 2, which will give us 75. So hence we'll have 75 as the interval median there, midpoint, sorry. So from there on, we'll get a mark for each of these midpoints. You get a mark for the cumulative frequency that you are having there, and you get a mark for the column of the product between our midpoint and the frequency. Midpoint times the frequency. Like that. So 30 times 125, it will give us that. So that's what we multiply. Now, we have to calculate the estimated mean for the liters of water used by each household. Remember the definition of our mean. It is X bar is equal to the sum of all data items. And if you check the sum of the data items, we added it as a total there, we will get 100,000 liters, and we are dividing this by the cumulative frequency, which is 400, and this will give us 50 liters as our estimated mean there. Now, we have to draw an Ogive of the above data on the grid provided in the answer book. No, we did not provide you with the grid, so therefore you will draw your Ogive there, and our Ogive should look like that. Remember, when we are drawing an Ogive for the interval, it is 100 and the cumulative frequency. The upper value of each interval and the cumulative frequency of each of the given intervals, and we'll get a mark for the upper limit. We'll also get a mark for the shade as well as the grounding there. Our smallest value in the interval is 50, so we must have another point with coordinates 50 and 0, which is going to help us get those 2 marks. We use the Ogive to determine the median of the data set. Remember the median, it is always, remember the formula for finding the median, it is half n plus 1, in which case we can use half 200, sorry, it's half 400 plus 1, and this will give us 200,5. But if you look at our graph, we have to round this down to a reasonable number, so it is the same. Whether I use 200 or 200,5, it should give me the value of our median. So you will go on the frequency side, you use a ruler. When you reach your graph, you then go down and you take your reading down there. And if you check, our median will be equal to 250 liters. Now we have to comment on the skewness on the next one. You will find out that to comment and give a reason, remember we said for us to comment correctly on the skewness, we use the mean and the median. If you check, we calculated our estimated mean, we found 250 liters. Our median is also 250 liters. So in other words, our X bar is equal to the median. Therefore, we can conclude that this is symmetrical. Why is it symmetrical? Because the mean is equal to the median. So that becomes your comment, that becomes your reason. The mean is equal to the median. That's how we arrive at that conclusion. We move on to question 1.6. Now, we are told that a sample of residents were asked how many liters of water they use per week. We have that. The municipality restricted the usage of water due to water shortages. The residents may not use more than 300 liters of water per household per week. How will this affect the standard deviation? Now, remember, from grouped data, we are also able to find our standard deviation for the data. So, we have our data. What will happen to the standard deviation? Now, it means our estimated mean will go down as well. If it becomes smaller, it will also mean our standard deviation will increase because there will be more spread now of the data around the mean, and we are saying the values will be further from the new mean, and that is why we are saying the standard deviation will increase, because remember, standard deviation, we are talking about in a normal distribution, we are talking about that where we have our mean. So it means the further this is to the left, to the right, it will affect our standard deviation. Now we move on. Now here is a second activity that I would want us to quickly look at. Now this is extracted from our Gauteng prelim. Try to draw the Ogive and you complete the cumulative frequency column. I will give you 4 minutes to do this. welcome back. Now, I would want us to quickly do a demonstration of how we plot our cumulative frequency graph. So now, remember, these are monthly salaries in thousands. So if I have 10, it means it's 10,000. If I have 20, it means it's 20,000. So it's between 10,000 and 20,000 and so on and so on. Now, for us to complete the column for cumulative frequency, we always say we write the first frequency, it will be 3. To get the cumulative frequency in the next row, we'll go 3 plus 4, and that will give us 7, plus 13, it will give us 20, plus 20, this will give us 40, plus 21, this will give us 61, plus 12, that will give us 73, plus 12, this will give us 85, plus 8, this will give us 93, plus 5, it will give us 98, plus 2, that will give us 100. That's how we complete our cumulative frequency. So we should be able, sometimes they will give us 3, 7, and then they jump the other one. We should be able to deduce it there using this method that I'm showing you. If they put a B in place of that 20 and they give you the cumulative frequency there and there, you are able to subtract in order to get the value of the missing value there. So we should be able to work either way. And we said, for us to draw our cumulative frequency graph, these are the points that you will plot. You will plot 10 and 3. You will plot our 20 and 7. You plot 30 and 20 using cumulative frequency, 40 and 40, and so on and so on. And the last point will be 100 and 100. So these ones, whichever is the highest value here and the cumulative frequency there, those are the points that you must be plotting. So I'll suggest quickly do it on your table so that you know which points you are plotting. And remember, we need to always ground. So 10 and 3 is the first point that you are plotting, but where do you ground it? At 0 rand. So you must have another point with coordinates 0 and 0. That is for grounding. You must have that point. 10 and 3 will be somewhere there, and so on and so on. From there, you join the points. And our cumulative frequency graph would look something like that. So you are looking at 40 and 40, that is the point, 0 and 0, 10 and 3, 20 and 7, and so on and so on. We get our cumulative frequency graph. It was 4 marks. So for plotting that end point, for the shape, grounding, and plotting the correct cumulative frequencies there that you are having, you will get all the marks. Moving forward, we are using now the Ogive to determine the number of employees that receive less than 35,000. So we are going to use our graph. So the employees that, so 35,000 will be between 30 and 40. So somewhere in the middle there, you get to the graph, then you are able to move to the left. And you should get a number of 30 employees there. But we accept, because some of us, when we are using freehand to join the points, we can go either up or down along the way. So we accept a range of values. So any value between 29 and 31 will be accepted. So we are accepting 29, 30, 31. The median for the data, our cumulative frequency is 100. So the position will be 1 over 2, 100 plus 1 divided by 2, and it will be half 100 plus 1, and that will give us 50,5. But You can round it down to 50. So you will find out that our median is around 45,000 and would accept 44,000, 45,000, 46,000. This one, you can give an answer of 44,500, 45,500 because you are estimating that one. But do not give weird estimates like 44,362. It becomes a bit overboard. So let's give reasonable ones. And then our next activity, I want us to answer this question 1.41 and question 1.42. Please read the whole information. Let's read the whole story there and we answer those questions. I will give you 4 minutes to do that activity. Welcome back. Now, as I indicated, please read the whole information before answering. And I know some will be laughing because they made that mistake. The monthly salaries of 5 employees in the interval 80,000 to 90,000 are given as below. Now, we are told 2 employees from the interval 70,000 to 80,000 are promoted and receive monthly salaries of 83,000 and 84,000. Can you see now? These two, we are adding them there. We have one with 83,000 and we have one with 84,000. So our data items, it means we have 1, 2, 3, 4, 5, 6, 7. And the common mistake that we made is to just use these 5 and we did not read the other bottom part, and therefore our mean and our standard deviation will not be correct. As you can see, it's 1 mark, which means it's a mark for accuracy. We must get the correct mean, otherwise we won't get anything there. So to determine the mean monthly salary, we add these 7 data items and we divide them by 7 and we get our mean as 85,857.14. And then the standard deviation for this interval, we should get 2,294.63 rands. So for the answer there. And then we move on to the next part. We have to determine the percentage of employees whose monthly salary lie within 1 standard deviation to the mean. Now, remember, for us to get that, we must get our mean minus 1 standard deviation, mean plus 1 standard deviation. We get our interval as that. We get a mark for it. And then within 1 standard deviation, we are having 4. So for the number 4, for counting the correct number of employees, and for the percentage, we get our 3 marks. Now remember also, it can be outside, it can be lower than, it can be above, or it can be outside. So we should be able to work out whichever is asked there. We move forward to analysis of 2 variable statistics, and we are saying here we are using the correlation as a statistical measure that expresses the relationship between the 2 random variables. We use a scatter plot where we plot the points. One is an x variable, the other, where they intersect, we indicate that point. And from there on, we plot the corresponding y values in the Cartesian plane, and we use the equation of the least squares regression line, which is written in the form y bar or y hat is equal to a plus bx. Now remember, this takes the form of an equation of a straight line. Our a is the y-intercept of the line and b is the gradient. Now the line of best fit, or the least squares regression line, always passes through the point with coordinates x bar and y bar, which is the average for the x values and the average for the y values. Now we also look at the trend and the correlation trends. We have a linear, a quadratic, as well as the exponential. But for our purposes, we'll only look at the linear correlation, where we draw a straight line of best fit. Then we have that one which takes quadratic, and we have another one which takes the exponential form. But for now, we will not be concentrating on these ones. We'll only concentrate on the linear correlation. It's just for knowledge's sake. We move on. Now, the linear correlation between the 2 variables is known as the line of best fit, and we say the correlation can either be negative or positive. And we say if it is positive, you will find the line of best fit will have a positive gradient, and if it is a negative correlation, the line of best fit will have a negative gradient. As the x values are increasing, the y values are decreasing. Whereas for a positive correlation, as x values are increasing, the y values are also increasing. And then we have where we do not have a correlation. We use a correlation coefficient, which is the value between -1 and 1. It's an interval. And we are saying the correlation coefficient can either be strong, weak, moderate, and it can either be positive or negative. So it goes with the sign of whatever we get as the value of the correlation coefficient. Now, if the points are close together and they're increasing, it means there's a strong positive correlation. If the points deviate from the regression line, there will be a lower correlation coefficient. The correlation, we say it's weak. And just the description of how we get. If points are fairly spread out, there is a fair correlation in either a positive or negative sense, and we are able to represent our correlation coefficient table so that we see how to comment on the correlation between the points. Now, between -1 and 0, our correlation is negative. It can either be weak, moderate, strong, or very strong, or perfect. If it is equal to -1 in the positive sense, it also works like that. The line of best fit, we said the points have to pass through the coordinates x bar and y bar, and we are saying it relates to our bivariate data. We know that we need 2 points for us to draw a line of best fit, but remember, our line of best fit should not go beyond the points that we are given. I will explain this further. If our minimum x value, for example, is 10 and the first point has 10 and 12, we can't proceed below that point. We have to terminate our line of best fit there. I will explain this later. So when we connect points, we use the straight line, and we are saying it is most likely to predict any of the values correctly between our minimum and our maximum points that we have plotted there. Anything outside, we cannot trust. So that is interpolation, where we use our regression line to estimate the y and the x values that lies between the smallest x value and the largest x value in the given data set. Now, extrapolation is the practice of using the least squares regression line to estimate y values for an x value that is greater than or the greatest x value or smaller than the smallest x value in the given set. But we are saying this should not continue beyond the interval, the smallest and the greatest x values, because beyond the range of values, it cannot be trusted. Now, this is the question that you wrote. I will not waste time because I know you have done corrections for this, so I will just go over it with you together. We use our calculators, 2 variable statistics. We enter our x values onto our calculator. We enter our y values. We save, and then we go to statistics mode. We are able to get our value of A, and we got our value of A as 0.0478072, and our B value is 0.067704. Now we get our equation as y is equal to 0.05 plus 0.01 x. Remember, this is to 2 decimal places. So for the A value, you get a mark, B value, you get a mark, and for the equation, you get your third mark. I'll always encourage you to always Write the value of A, write the value of B before you substitute them into the equation. Just in case you swap them around, you will get marks. You get 2 out of 3 in case when you substitute them in the equation, you swap the position of A and the position of B. We must always make sure that we get those marks. We use the regression line to predict the length of the 18-year-old boy if he does 110 leg presses per day. So let's look at that one. He's 18-year-old and he does 110 leg presses. We have to find the Y value or the strength of the upper leg. So how do we do that? We substitute into the equation and we get 1,15 as the strength, or when we use the values without rounding them off, we should get this one as 0,79. Again, for substitution answer, you get 1 mark. So you can either use that or you use this. Don't waste time and do both. We move on now. We are told that one 18-year-old boy did 250 leg presses per day. Can your regression line formula predict the strength of his leg? Explain your answer. This is what we meant. Now, if you check, 250 leg presses is above the interval. If you check on our interval, the minimum done there is going to be 36 and the maximum leg presses done there is 136. So that's our minimum X value. This is our maximum X value. Therefore, 250 leg presses is outside the interval. So our prediction there cannot be trusted. The next question, we are saying calculate the correlation coefficient of the above data. We are using our calculator. We'll get our R as 0.97. We get our 2 marks for just reading. Here you give a valid explanation. Extrapolation, remember it's outside the minimum and the maximum X value. So question 2.5, we are supposed to use the answer in 2.4 to describe the relationship between the number of leg presses and the leg strength of an 18-year-old boy. So now, remember, I said we have our correlation coefficient, and I know that this one, there is a very strong, so you get a mark for the positive and for the comment, strong correlation. There's a very strong positive correlation. So you get a mark for the comment as well as commenting whether it's a positive or a negative relation. There you get your marks. Now, I would ask you to answer the question from Gauteng Prelim. You will see there's a similarity there. Let's answer question 1.1 up to 1.3, and I'm giving you 4 minutes to do the answers there. Welcome back. Now, this one will require us to work with our calculators. So to calculate the to calculate the least squares regression line equation, remember we use our two variable statistics mode. We enter our data items. So if you check there on the table, they do not indicate which one is the X, which one is the Y, but you are able to see also on the graph our number of customers, it's our independent variable, and the amount in rands, it's the dependent variable. So this becomes our Y, and that one is our X. So we will get our A as 12,59627,329. Our B, we got it as 17,32. So value of A, value of B, then we get our equation as Y is equal to 12,60 plus 17,33x, we get our 3 marks. Predict the amount. When we are predicting, so we want the amount, we are given the number of customers, so 11 is our X. Where there is X, we substitute with 11, and we should get our Y as 203,23. That is the amount in rands. Or if you use the rounded off figure, you'll get a different answer. We determine the correlation coefficient for the data. We get 0.95. Round off to 2 decimal places, it's 0.95. We get 1 mark. So mark for that, and a mark for substitution, and a mark for the answer. We move forward. Now, 2.4, the organizers of the event think that there was a very weak positive correlation between the number of customers and the amount of money received at the stalls. Motivate whether you agree or not. I would say I do not agree, because my correlation coefficient of 0.95 is a very strong positive correlation. So that becomes your reason. You are looking at the value and then you comment. It's a very weak positive, yet you got 0.97, 0.95, sorry, which is a very strong positive correlation. Let me quickly go back. We are told that at another stall, 6 customers spent a total amount of 195 Rand. If this point is included in the data, will the gradient of the least squares regression line increase or decrease? Motivate your answer without any further calculations. Now, if you check, you have a point where you have 6 customers, so it is going to have coordinates 6 and 195. Looking at this, you are able to see that 9 customers, 185, 12 customers, 220, 13 customers, 245. So this point with coordinate 6 and 195 is very far from the least squares regression line. So you are able to say the gradient will therefore decrease. Why will it decrease? Because this point is further from the line of best fit. So that you have a picture of what is happening. If we substitute 6 into our regression squares equation, we will have our Y as 12,60 plus 17,33 times 6. It will give us an amount which is around 116, something rands. And 116 and that one, you will find that that point becomes an outlier because it is the furthest from all the other points that we are having there. Therefore, it will decrease the gradient, or the gradient will become less steep. Now, let's do the activity there. For Eastern Cape prelim, I will give you 8 minutes to answer those questions. 8 minutes. Let's answer the questions. Welcome back. Now, I will encourage you, if you look at this data set, the data is not arranged either in ascending or descending order. Therefore, you need to arrange it so that you are able to work with a sorted out data. Now it says the number of liters of diesel purchased by 15 truck drivers at a petrol station were recorded as follows. Write down the mode. Remember from the definition of the mode, the data item with the highest frequency. If I check, I have 88, I also have 88. So I can write down that my mode is equal to 88. I get 1 mark. 1 point, write down the range. How do we determine the range? It is the highest data item in the data set minus the smallest data item in the data set. So my highest data item is 98, my smallest is 41. Therefore, I would say the range is the highest value minus the smallest value, which becomes 98 minus 41, and this should give us 57 liters. The mean, we sum up all the data items and we divide them by 15, so our x bar will be equal to the sum. I think we should get 1104 over 15, and that will give us 73.60 as our mean. Now we have to calculate the standard deviation. We are using our calculators, and our standard deviation becomes, we should get 16.30 as our standard deviation. The next part, we have to estimate or determine the number of truck drivers that purchased diesel below 1 standard deviation of the mean. Remember? So now we are going to use our interval x bar minus 1 standard deviation, x bar plus 1 standard deviation. Check, it says below. So we might not need the whole interval, but we have to determine our mean minus that. So our x bar minus standard deviation, it becomes 73.60 minus 16.30. The 0 is just a placeholder there, and that should give us a value of, let's quickly do that, 73.6 minus 16.3, and that should give us 57.3. 57.3, that is the minimum value. So anything which is less than 57.3, I will have 1, 2, 3. So my answer there becomes 3. My answer there becomes 3. Determine how many drivers, so the answer becomes 3 drivers. So therefore, 3 drivers. So for getting the substituting into x bar minus that, getting 57.3 as the minimum value, and then counting correctly, we get our 3 marks. 1.2, we are told that the mean weight of 8 people entering into a lift is 75 kgs. The lift has a weight limit of 1,000 kilograms. How many people can still get into the lift, assuming that the mean weight remains 75 kgs? Now, this is an application question where we apply our knowledge of calculating the mean to help us get that. So we start, first of all, for 8 people, we are saying their total mass, which I'll call x, divided by 8, should be equal to our 75 kgs. That is our mean. Now, from there, If I cross multiply, it means the weight of these people becomes 8 times 75, and 8 times 75 should give us, sorry about that, let me quickly go back. Just a moment, we want to fix something here. 1 minute, we'll be back.
I want you to ask yourself these 3 questions. Number 1, what do I want? Do I want to become an A student, or do I want to become an average student? Number 2, I want you to ask yourself, how do you plan on getting there? Are you going to put more extra hours, or are you going to just sleep? Number 3, who will be with you in this journey? Because it is important that we associate ourselves with students who have the same vision as us, who want to become a student, who want to put in the extra work, who want to become better at what they do. Unsuccessful people do not plan. They just let life happen to them. But successful people are planning on how they want their lives to be. And right now, you plan on how you want your results at the end of the year to be like. Believe in yourself. Believe a little more in yourself. Because to those that believe, nothing is impossible. You have done this before. You have passed your tests before. You have went into a higher grade before. It is possible because you have done it before. Do not doubt yourself. Keep believing in yourself. Keep pushing, because this can be done and you can be great. The road to success is to commit to yourself. In order for you to become who you want to become as a student, you need to commit to reading your books, to studying, to bettering yourself.
Welcome back. Sorry about that. So this will give us a mass of 600 kgs. And now we want to see how many people can still get into the lift, assuming that the mean weight remains as 75 kgs. So this is the mass of 8 people. It's giving us 600 kgs. So we want to find out the weight of more people that can fit in, and this will be 1000 kgs minus 600 kgs, and this will give us 400 kgs. Now, to get the number of people, it will become the 400 kgs divided by the mean weight, which is 75 kgs, and this should give us 5,33. But we cannot have a 0.33 of a person, therefore we would say 5 more people can still go into the lift. It's an application, nice question. We must be able to answer such questions. Now, we move forward now to our grade 12 statistics. Because of time, I will ask you to take a photo of this activity where we are asked to describe the correlation between the number of heaters sold and the average temperature per month, and we verify our answer by referring to the correlation coefficient. So please check. If the temperature was 2 degrees, 98 heaters were sold. 7 degrees, the number of heaters sold was 100, and so on and so on. So we should be able to punch in our data. So Temperature is our independent variable that becomes our x, and the number of heaters sold becomes our dependent variable y. So we enter our data items and we use them. So if you calculate, you will find out that your correlation coefficient is going to be a very strong negative, and you are able to see that it will be negative 0.97. Now strong negative, negative 0.97. So you have calculated this, you got this from your calculator. 2.2, we are supposed to determine the equation of the least squares regression line for the data. And we get our A as that, our B as negative 3.82, and the equation becomes that. Quickly, we move on. We have to predict the number of heaters sold for a month where the average temperature is 20 degrees Celsius. So we will substitute our X value and get our Y as 28 heaters. We move on to 2.4. We are supposed to draw a line of best fit, and you are able to see that our line of best fit has to pass through our X bar and Y bar there. And also check that our graph has to be restricted. It can't go beyond those points if you are drawing it there. The moment you extend it, you lose marks. We move on now to calculate the standard deviation of the number of heaters sold. This you get from your calculator, and we get it as 34.13. We are looking at the standard deviation for our Y values. Now, in summary, we are saying we have to use our calculators to perform calculations of measures of central tendency and solve statistical problems. We must be able to determine the 5-number summary and use it to draw and interpret a box and whisker diagram or plot. We have to plot and interpret an Ogive, our cumulative frequency curve, and we should be able to also determine a box and whisker plot from an Ogive. Sorry about that. And we are saying we must be able to use our statistical summaries, measures of central tendency and dispersion, and our graphs to analyze and make meaningful comments and conclusions on the context of the associated data given. A scatter plot is used to represent the analysis of bivariate data, and the correlation coefficient is used to determine the strength between the relationship of the two variables. I thank you. Please go and also do the worksheet that we have added there for your own practice. Statistics, we must get all the marks. I wish you all the best as we continue to practice mathematics. Let's meet again next week. Enjoy the rest of your evening.